Good morning. Today I'm going to go through Unit 3, Lesson 3.2, Parts of a Graph. Today is Tuesday, February 2nd, 2021. I'm going to start with a warm-up question. The question says, answer the questions about the following polynomial. -5 minus 1/4 x squared. Okay, the first thing that I want to do in order for me to answer these questions is I'm going to put it into standard form. Standard form, remember, is in descending order from highest power down to lowest power. So I'm going to rewrite this as -1/4 x squared minus 5. Rewriting it helps me to better answer the questions below. The expression represents a, because it's a second degree, it's raised to the power of 2. That is a quadratic polynomial. Okay, there are 2 terms, so it's a binomial. The constant term is -5. And the leading term is -1/4 x squared. And the leading coefficient is -1/4. Okay, that's just a little review from the material that we went over yesterday. Now we're going to look at characteristics of a polynomial function. The first thing that I'm going to do with this polynomial function is to stick it into Desmos. That is a great practice for you to do every time you're given a polynomial. It'll help you to describe and look at the features of the polynomial function that you're given. So I'm going to open my Desmos tab, x to the power of 3 plus 6x squared plus 8x. So I'm going to type that in. Okay, y equals x cubed plus 6x squared plus 8x. Okay, so I'm going to take a look at Desmos. I'm going to kind of highlight some of the features here. I see that it has 2 turning points. Here's a turning point. Here's a turning point. This is my relative maximum. -3.155, 3.079. This is my relative minimum. -0.845, -3.079. I have 3 x-intercepts, -4, -20, and 0. Okay, let me go and put that information onto our note sheet. Okay, I'm going to put the zeros first. -4, -2, and 0. Okay, did it ask for the zeros? Oh, yes, it did. Okay, so let's go x equals -4, x equals -2, x equals 0. Or I could have written them as ordered pairs like they're given to you in Desmos. Okay, let's do the turning points, number of turning points. Remember yesterday we said turning points was degree minus 1. So 3 minus 1 is 2 turning points. We know it's a cubic polynomial. It's actually a cubic trinomial. There's 3 terms. So the parent function is going to be y equals x cubed. Domain and range of all cubic functions will always be all real numbers. So negative to positive infinity. There are no restrictions on the domain. Okay? It did not ask actually for relative maximum and relative minimum, but those turning points will help us to determine our intervals. Okay? So let's look again from -infinity to -3.155, the interval, your y's are increasing. So I'm going to go -infinity to -3.155. Okay, go back from -3.155 to negative 0.845, we're decreasing. Negative 3.155 to negative 0.845. And then back from negative 0.845 to infinity, your y values are increasing. So I'm just going to use my union symbol, negative 0.845 to infinity. Okay, end behavior. Yesterday, we looked at the end behavior chart. I can use that, or I can just look at my Desmos. I know it's a positive leading coefficient. It's a positive 1, and it's an odd degree. So positive odd has the end behavior down, up. Left-hand side's down, right-hand side is up. So my statements, as x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y approaches negative infinity. And that is the ends of the graph. That is what the end behavior is doing. Okay, and I could sketch it, but we see it in Desmos, so I'm just going to keep going. My sketch will look kind of crazy with my drawing tool here. Okay, next example. We want to determine the following characteristics: the type of polynomial function, domain, range, end behavior, turning points, relative maximum, relative minimum, zeros and their multiplicity, and the effect of the multiplicity on the graph. Okay, so let's determine a few things first here. We see that it is a quintic polynomial, okay? Quintic polynomial. So our parent function is y equals x to the power of 5. Okay? Quintic polynomial. It is a positive leading coefficient with an odd degree. So again, from our chart yesterday, we know that's down then up behavior, end behavior. So as x is going towards positive infinity, y will be going towards positive infinity. As x is going towards negative infinity, y will be going toward negative infinity. The domain and range, it's a quintic polynomial. Our domain and range will be, we can look at Desmos. Let's go ahead and stick it in at this point so that we can find all of the other characteristics that we're being asked to find. So x to the 5th, I'm just going to erase this one, x to the power of 5 minus 6x to the 4th minus 6x to the 4th plus 8x to the 3rd plus 6x squared minus 9x. Oops, not the 6. Okay, woo, what a cool looking graph. Okay, so let's see, I see it's going, again, our end behavior, there's no restrictions. So that means that, again, our domain and range will be all real numbers. So I'm just going to put domain, and I'm just going to put slash range, negative to positive infinity. Okay, let's look now at relative maximums and relative minimums. I may not write these, I'm just going to highlight them on Desmos. Okay, I have two relative maximums here and here. Those are our relative maximums. Okay, now I have two relative minimums here and here. Remember in Unit 1, we talked about peaks and valleys? Your relative maximums. There's no absolute maximum because it's extending to positive infinity. There's no absolute minimum because it's extending to negative infinity. These are your relative max here that I'm circling. These are your relative minimums. Let's look lastly at our x-intercepts in any multiplicity. We have 4x intercepts here. 4 solutions, roots, zeros, okay? 4 distinct. However, because it's a 5th degree polynomial, we know there has to be 5 zeros. One of the zeros has a multiplicity. Multiplicity means it's a repeating zero. Okay, so let's look. The graph crosses the x-axis at -1. That's a multiplicity of 1. 0. That's a multiplicity of 1. 1. That's a multiplicity of 1. When a graph bounces off the x-axis, that indicates a multiplicity of 2. That is a double root, okay? So it has a double root or multiplicity of 2 at x equals 3. All right, let me go back here, and I just want to write that and then show you what that would look like in factored form. Okay, so we know our zeros are x equals -1, x equals 0. Was it x equals 1? Yes, x equals 1. And then x equals 3 had a multiplicity of 2 because it bounced on the x-axis. A graph can bounce coming up from the bottom or coming down from the top. Whenever it bounces off the x-axis, it's a double root, okay? I'm going to take these zeros and just represent it for you in factored form, okay? It's just something that you're going to learn within the next few lessons. Because x equals -1, that's going to be the factor x plus 1. Because x equals 0, that's just going to be a standalone x. I'm going to stick that at the front. X equals 1 is going to be the factor x minus 1. And then x equals 3 is going to be the factor x minus 3. And I'm going to raise it to the power of 2 because it is a double root. Okay? So the factored form would be here. Y equals x, parentheses x plus 1, parentheses x minus 1, parentheses x minus 3 squared. Okay? So just make yourself an additional note. Double roots bounce off x-axis. Just going forward, understand that if the graph lies on the x-axis, that's going to be a triple root. Let me show you really quick, okay? Let me just do an example. I'm just going to do it in factored form. I'll go x plus 3, and then I'll go x minus 2, and I'm going to raise it to the power of 3. Okay, look, the graph cuts through at -3. It intersects. Look what it does at 2. It lies on the x-axis. So bounce is a double root, lies on is a triple root. Okay, you can see that it lies on when I zoom in. That is a triple root. I'm sure we'll see that over the period of the next few days. Okay, we're going to keep going here. How many more do we have? 1, 2, okay. All right, let's look at this next function. They want us to do the same thing. Type, domain range, everything. Okay, so first type. It's raised to the power of 3. It is a cubic polynomial. I'm going to utilize some space over here. Its parent function is y equals x cubed. Okay, its leading coefficient is -1. Its leading power is its highest exponent is to the third power. Obviously, it's cubic. So it's end behavior because it's negative and it's an odd degree. Its end behavior is going to be up, then down. So as x goes towards positive infinity, y goes towards negative infinity. As x goes towards negative infinity, y goes towards positive infinity. Okay, and we can see that when we stick it into the Desmos. All real numbers for domain and range. There are no restrictions on the cubic polynomial, domain and range. Okay, let's stick it in, look at the relative max, relative min, zeros, and their multiplicity. Okay, so let's stick it in, negative x cubed plus 15x squared. Y equals negative x cubed plus 15x squared, oops, minus 75x plus 125. All right. Ooh, this is cool looking. Okay. So I have, look at the graph. Look what it does at 5. It is lying on the x-axis. We just talked about that. When a graph lies on the x-axis, as such, in this picture, in this graph, we know that that is a triple root. Okay? That is a triple root. So I'm going to go back here. X equals 5. The multiplicity is 3. Okay? Lies, make yourself a little note. Lies on X axis. Remember, we said double root bounces, triple root lies on. Okay? All right, let's keep going here. This will bring us back to a little bit of what we did yesterday. Remember, real quick, the degree, even, odd, the leading coefficient, positive or negative, up, up, down, 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 up, up, down. Right? We did that chart yesterday. So this can help us determine the degree and the leading coefficient. Number 11, both ends are going down. That's easily matched the fact that it's an even degree and that it is a negative leading coefficient. Number 12, I see them going in different directions, the ends, so I know automatically it has to be an odd degree. And because it follows down then up, it is a positive leading coefficient. Okay, make sure you have this chart down in your notes if you didn't do it yesterday, because it will help you with determining the end behavior. Okay, last example here. Graph the function, identify all of the key characteristics. Negative x cubed plus 8x squared minus 15x. So I'm going to simply stick it right in. Y equals negative x to the power of 3 plus 8x squared minus 15x. Okay, let me zoom out a little bit. All right, so let's identify some of the key features here. Our x-intercepts, or our zeros, I have it intersecting at 0, 0, 3, 0, and 5, 0. It's a third degree, or a cubic. There's 3 distinct zeros. They all have multiplicities of 1 because they intersect through the x-axis. Okay, I have a relative maximum at 4.12, comma 4.061. I have a relative minimum at 1.214, comma negative 8.209. I have a negative leading coefficient with an odd degree. So let's kind of fit this information in here. Okay, domain, of course, all real numbers, no restrictions. Range, same thing. Let's go back, relative maximum, there's 1. I'm just going to say 4.1, comma 4.1. I'm just going to round to the nearest tenth. And then relative minimum, 1.2, comma negative 8.2. Okay, as x approaches positive infinity, that's right hand end behavior. As x approaches positive infinity, y is going toward negative infinity. As x approaches negative infinity, y is going towards positive infinity. Let me write the zeros really quick. The zeros were 0, 3, and 5. Okay, and again, you could write them as ordered pairs also. Increasing intervals. There's only one increasing interval from 1.2 to 4.1, right? I'm going to, with my mouse here, oops, from 1.2 to 4.1. When you ride the roller coaster, you can see it's going increasing. 1.2, comma 4.1. Okay, it's decreasing. 2 different intervals. Negative infinity to 1.2, and then 4.1 to infinity. Okay, let me just put an arrow here, and that way I can write over here. Negative infinity to 1.2, union 4.1 to infinity. Those are it has 2 intervals of decreasing. Okay, that is it for today. Parts of a graph. Make sure that you use Desmos to help you to identify these features, and have a wonderful day.